Let's talk about master and nodes. A Kubernetes deployment is generally referred to as a Kubernetes cluster. So you might ask, what is in the cluster? To answer that, the answer is master and nodes. Where the master manages all cluster activities and your requests, while the node is where the work happens, a worker machine or a worker node. A node is typically a virtual machine or a VM. Let's go a little bit deeper into master and nodes and look at the individual components within master. The components within master which you will interact with are the Kube API server, the Kube scheduler, and the Kube controller manager. Kube API server, it is the component on the master that exposes the Kubernetes API. We'll actually be using the Kubernetes API quite a bit using kubectl commands, but we'll cover that later in the practical. It is the front end for the Kubernetes control plane. Basically, when you issue commands to your cluster to perform an action, for example, deploy something, this is the component that receives your commands. You'll see the use of these commands in the practicals. The Kube scheduler. It is the component on the master that watches newly created pods that have no node assigned and selects a node for them to run on. It basically manages the resources available on the Kubernetes cluster and helps manage the launching of new pods. And we have not discussed what pods is yet, and we will come back to this in the next section, to where there are available resources. The Kube controller manager. Component on the master that runs controllers. The controllers have many functions, and we'll touch on them in the practicals, but the two major controllers you should know about is the node controller, which is responsible for noticing when a node dies, and replication controller, which is responsible for maintaining the correct number of pods. Let's dig a little deeper into the node. The components within node that you should know about is the kubelet, the kube proxy, and Docker. Kubelet is the primary node agent. The kubelet does the following. Watches for pods that have been assigned to the node. It runs the pod's containers via Docker. It interacts with Kube API server in the master to update the status of each pod back to the cluster master. The kube proxy enables the Kubernetes service abstraction by maintaining network rules on the host and performing connection forwarding. This is the bit hard to digest right now, but after we go through the services section, you'll understand the functionality of this component more clearly. And obviously, Docker needs to be installed on the node to actually run the containers, as Kubernetes doesn't run the containers, it just manages the containers for you. As such, it is an orchestration tool. So after digging it a little deeper, we found out what defines each of the master and node in the Kubernetes cluster. As you can see in the diagram, the node has to have a kubelet in Docker installed for it to be considered a node. Now, let me ask you a question. From the diagram seen before, is it true that master and node are separate VMs, for example? As you can see, master is here and the nodes are over there. So would you say that the master is a VM and then the nodes are VMs by themselves? So you have a separate VM for the master and separate VMs for the worker nodes? It seems that way. However, this is actually being changed. Currently, many default settings will allow master and worker to be on the same VM. This is actually preferred in most cases because you can use the available resources that's not used on your master VM to launch pods as well. So in short, a master can also be a worker node. A more accurate diagram will look something like this. What defines a master is actually just the master components that we have discussed before, the Kube API server, the Kube scheduler, and then the Kube controller manager. So as long as you have these components, it makes up the master. And the same for the worker, as long as you have a kubelet, a kube proxy, and Docker installed, you'll have a functioning worker node. And so in this simple diagram, you can see that the master and the worker coexist on the same virtual machine. Let's say it shares the same memory, and it shares the same disk space as the virtual machine. And for our practicals, this is what will be done. We'll only launch a single VM with both master and worker node. And of course, you can configure the system so that the master is by itself in a separate virtual machine than the worker virtual machines. However, this might not be desired in most cases. Practically speaking, many of the components mentioned above for the master and nodes, for example, the Kube API server, the Kube scheduler, Kube controller, so on and so forth, are background processes, and in most cases, you will not be interacting with it directly. We'll be mainly controlling the cluster in a high-level manner by interacting with the Kubernetes API, which is served through the Kube API server on the master. Using the Kubernetes command line interface kubectl, in the practical, we'll do everything using kubectl, and you'll get hands-on experience using this command line tool.